Good morning, friends. So today we are going to discuss method of section. That is second method to analyze the truss. So you must have seen the method of joints. If you have not seen, you can go through it. And if you are facing any problem, you can put it there. And today we are going to discuss method of section. Now, what is method of section? Basically, it is based on principle of say rigid body equilibrium. Method of joint was based on principle of point equilibrium. So because every of the joint was a particle, so we were supposed to, when we are solving a problem with method of joints, we were using free body diagram of all the joints, treating all the joints as particles. Now the conceptual difference in method of section and method of joint is, here we will cut the truss in two portions. Each of the portion will be called a section, and one of the section is going to implement force on another section. That means out of one rigid body we are going to make two rigid body, and that is how we are going to solve the problem. So let us see this. I have taken a question again from a standard book, Beer and Johnson, example number 6.2. It's a solved example just to illustrate you what is the method of section. So this is a good book, and yes, you can follow such kind of standard books for conceptual understanding. So this is a question given to you. You can see this is a truss given: A, B, C, D, E, F, G, H, I, J, K. Now the forces which are there, and you see what are the external forces. One force is here, 28 kilonewton at C, 28 kilonewton at G, and 16 kilonewton at K. It is horizontal, and these two are vertical downward force. There are two kind of supports. One is a hinge support at B, and there is a roller support at J. All the horizontal span is 8 meters. It is all 8 throughout, and vertical is 10 meter. Again I am reminding you and giving you a careful understanding that angles can be given in the questions directly, or you may have to calculate the angles from the given dimension. Do not assume angle yourself. Do not assume that all angles are always going to be 60 degree or 45 degree. That is a common mistake which used to be very frequent by the students in the paper of engineering mechanics. Okay, so let us proceed to see. Now they are asking only two forces, EF and GI. This is again fundamental difference when we are applying method of sections. Normally in the question, people are not going to ask you all the forces. If they will ask you all the forces and do not give any choice, you can apply method of joints. So if you have to solve a truss for all the forces in the truss, then method of joint is better. But if you have to solve a problem where you have to just solve one or two members, then method of section is going to be better. If the choice is left to you by the examiner, then for more number of forces if required, you go for method of joints. If less number of forces required, you go for method of sections. Okay, let us proceed. Now they have given us only two members which are required to be determined, EF and GI. So definitely method of joint is going to be very lengthy. If we want to calculate EF and GI, that means we have to find out or solve many of the joints which are not at all required unless we reach to the point G or F to determine the things. So let us see how we implement method of section here. So step 1 is same as I told you in the method of joints. Whenever there is a support like hinge and roller, there are three unknowns, and in such situations, except in cantilever beams, only in cantilever beams we will leave it aside, and all other questions our first step is going to be to determine support reactions. So we have replaced hinge support with two unknown, Bx and By, and Jy, that is vertical at J. Now we will implement three equation of equilibrium. So we have implemented movement about B taking anti-clockwise. This is a conventional notation. Anti-clockwise is positive, is equal to 0. So it is going to be 28 multiplied by 8. Direction of rotation, if you will see, this is going to be clockwise. about point B. So that's why it's negative. Again 28 line of action is coming here, turning it like this. So again it's a clockwise. So 28 into this is 8 plus 8 plus 8, 24. Okay, so 28 into 24, then 16 into 10. Now this 16, if you see the line of action, it is coming here, perpendicular distance is 10. And how it is going to turn? It is going to turn like this. It is going to turn like this. So it is going to be clockwise. That's why it's again negative. Then jy is acting here. So it is going to turn about this point like this. So you have to take movement about B, keep B fixed, try to implement force and try to see how it will turn. So it is going to turn in the anti-clockwise direction. So jy into 32, because 8 in 8, 8 and 8, you will add 8 4 times, it will come 32. So with this equation you can determine jy is equal to 33. Then second equation is summation fx is 0. So you'll have bx, horizontal force is bx, and 16. So bx plus 16 both are towards right, so both are positive. Bx plus 16 is 0, bx is minus 16 kilonewton. That means bx is going to be towards not right, towards left. Then summation fy, it will give us by plus jy minus 28 minus 28. There are two downward forces and there are two upward forces. We are assuming complete truss as one rigid body and determining the unknowns. So we are able to do step 1. Either we were using method of joints or method of section. This step is mandatory for both the steps, both the methods. Okay, so let us proceed now to understand what is method of section and how to implement it. Now method of section is very important in the aspect that it is a little bit tricky. So we are supposed to cut the truss in two portions. How to cut the truss? Your cutting line, that is, you are going to cut it like you are cutting it something like this, but if you see, this is a plane, okay, because truss is three-dimensional, so this is going to be plane. So cutting line or plane should cut members only. It should not pass through the joints. Okay, it should cut only members. This is very important concept. Try to understand these all concepts. Prefer to cut maximum 3 members. It is expected that you will cut 3 members, and out of those 3 members, 1 will be the required members, or 2 may be the required members, or even 3 are maybe the required members. But you can cut maximum 3 members, that is what is expected. But in exceptional questions, there are some typical questions which we may discuss later on. You may have to cut 2 or 4 members at a time, right? The limitation is, because the more number of members you will cut, more number of unknown will come into the equation. And when we'll implement the equation of equilibrium, you can solve it for 3 unknowns. So that means if you are going to cut the truss and getting only 3 unknowns, then you are able to manage the problems. Otherwise you may have to be a little bit tricky to find out the unknowns. Let us proceed further. Cutting line should pass through members only. No joint should be cut. It should not cut any joint. No joint. You should not have a cutting plane passing through any joint. It should cut only members. Cutting line can be of any shape. It can be a straight line, it can be a arc, it can be a circular figure, or it can be any kind of figure. Okay, so cutting plane should be a cutting line can be of any shape. So here we have been asked 2 members to unknown. One is EF and another is GI, right? Now you cannot get these 2 members by cutting a plane once, because you cannot cut it like this. It is not going, you are going to cut 4 members, you cannot solve it. So what is required? We have to cut the truss twice. In some questions you will face this situation, that by cutting once you can get one unknown and then you have to cut the truss again. So we have cut the truss like this. Now you see this, we have cut in a manner so that EF is being cut. EF is the required member, but we have to make separate 2 portions. That means we have to cut the truss like this. So we are cutting 3 members, EG, EF and DF. Now here those members which we will cut, these internal forces which were internal will become external now. That means section 1, this is section 1 of the truss and this is section 2 of the truss. So section 1 will implement force on 2 and section 2 will implement force on 1 along these members. You can see this. This is like action and reaction from section 1 to section 2. So these are equal in magnitude but opposite in direction. So these are action and reactions. Now you can select any one section. You can select this section or you can select this section. Preferably try to see the section which is a smaller one or which is less complex. You select that for analysis purpose and try to implement 3 equation of equilibrium. So when I have selected this section now you understand what are the forces we have to consider. The forces which are implemented from an external side, that is like in this section there is a force of 28 kilonewton. The support reaction, if any support is coming in section 1, so support B is coming, so these two forces will be considered. And the forces in the members which we have cut, so F E G, F E F, F D F. So this is basically as we have done in conventional method, that is method of joints. So force at E is because of G is known as FEG, and we have taken all these forces away from the joint. That means we have assumed all these forces as tensile force. Now we can consider this section also, but not needed. We will consider this, you can do any one. Okay. Now we will write equation of equilibrium for this section. You see here what are the horizontal summation Fy we have written first. Now you can be a little bit tricky because the unknown what you want, if you can get, because one equation is sufficient to get one unknown. So method of section is tricky. If you can make out of 3 equations, you can make 3 equations here, summation Fx0, summation Fy0 and movement about a point is 0. So you can write 3 equations, but you can pick up any equations which can give you the required unknown. So intentionally we have taken summation Fy is equal to 0. So what are the forces coming? 23 upward, 28 downward and FEF downward. Okay, this is a horizontal force, will not come into equation. This is a horizontal force, will not come into the equation. 16 is an horizontal force, will not come into the equation. So that means one unknown is directly coming in my equation and I am able to get the unknown. FEF is minus 5. As stated earlier, minus indicate that what direction we have assumed of the arrows, that is wrong. That means not wrong, you can say its opposite answer is coming. So instead of tensile force, we are going to have compressive force in member EF. So your part 1, that is the you are able to solve the question where you are able to get the value of force in member EF and you are able to get more than 50% marks till here. Now let us proceed further. Now they have asked us to calculate force in GI. So we have to cut the truss again. So we have cutted the truss like this now. Okay. So again one section is this and one section is this. Now this side may be a little bit smaller. So I prefer to use this section to calculate or to get the value of FIG. Now this is again interesting that we can implement 3 equations, summation Fx0, summation Fy0 and movement about a point is 0. Now the most important equation is here movement equation, because we can listen carefully, we can take movement, suppose I am analyzing section 1. So I can take movement about a point which is in section 1 or I can take movement about a point which is in section 2, because the third equation of equilibrium is movement about z axis within the plane is equal to 0. So that means I can select anywhere. I can take movement about h, I can take movement about j, I can take movement about I can take about k. So we have to select a point in such a manner that line of action of most of the unknown pass through it and its movement becomes 0 and I will get the unknown within one equation. That is going to be the most productive way to work. So we are analyzing section 1 but we are taking movement about point H. What is the advantage? You see, one force, this force, movement will become 0, this force, movement will become 0. Say we are going to consider, what are the forces we are considering? 1, 2, 3, and then 1, 2, 3, this force externally and this force. Okay, externally implemented force, reaction, and internal forces in the member which has become external because of cutting the truss in two sections. This section is implementing force here, and this section is implementing force along these three members. So take the moment about this, see equation carefully. 33 into 8, this distance is 8. So we are taking distance from point H, we are taking moment about H and analyzing section 1. So it is going to be 33 multiplied by 8. How it is going to turn? It is going to turn in the anti-clockwise direction, it is positive. Then 16, line of action extend, you have extended the line of action, it will turn like this clockwise. So that is going to be negative. Fig is, its arrow is like this, it's like this, that means it is going to turn like this, that is going to be which direction? Anti-clockwise direction. So Fig into 10. So we have calculated Fig is equal to minus 10.4, minus indicate a compressive force. So this is the question which is giving you how to implement method of section. I hope this video is useful to you and you are clear with how to implement method of section. So you have to cut the truss in two portions. Method of joint is based on concept of particle equilibrium. Method of section is based on rigid body equilibrium. One rigid body is implementing force on other rigid body. We are making two section by cutting a truss in two portions. This is why known as method of sections. In method of sections, in a single cut you can get maximum 3 unknowns. In method of joints, if you pick up any joint you can get 2 unknown at the most. Okay, so that's all, and stay tuned. I will be sharing more videos, and whatever may be your requirement, you can write to me so that I can give you more videos on this topic. Thank you all listening to me.